In lesson 8.4, we're going to look at the applications of the quadratic equation, which means we're doing word problems. But before getting to the word problems, we're going to look at how we can solve formulas for a specific variable to help set us up for word problems. So we're going to jump right into an example. Here it asks us to solve the law of gravity equation for r. So that means that our variable of interest is r. And so they want us to put this formula in terms of r equals. That way, when we get to solving our problem, we can just plug in f, g, m1, and m2, and we've got r. So it just saves us some time once we've got the numbers plugged in. So how can we set this formula equal to r? Well, whenever we see a fraction, the first thing we should do is get rid of that fraction. To get rid of the fraction, we multiply by the denominator, which in this case is r squared. If we multiply this side by r squared, we also need to multiply the left by r squared. So then we have r squared times f equals, and then these two have canceled out, so we have g m1 m2. Alright, but now we have to get r by itself, so we have to introduce another fraction by dividing both sides by f. When we do that, we get r squared equals g m1 m2 over f. Alright, so we still have a fraction, however, now at least we have r by itself. We just have to get rid of that squared. The opposite of squaring something is to take the square root. We learned that in Unit 7. And so now these two things cancel out, leaving us with r. However, on the right-hand side, we now have to take the square root as well, because if we take the square root of the left side, we must take the square root of the right side. Just basic algebra rules. So that means that our final answer is the square root of g m1 m2 over f is equal to r. So that would be your final answer. So this is how you do it if you have something with a square in it, so r squared for example. What about if we have a square root sign and we need to solve for L? Okay, we're going to use the same rules that we learned in Unit 7 about squares and square roots. And our first goal, or our goal this time, is to get L by itself. So the first thing we have to do whenever we see a square root sign is get it alone. And this is something that a lot of people had problems with on the last test. So make sure you remember to get the radical sign alone first. To do that, we have to figure out how to get rid of this 2 pi. Currently it's 2 pi times the square root of L over g. So if it's times, we're going to divide by 2 pi to get rid of the 2 pi. Do that to the right, so we have to do it to the left. The 2 pi gets canceled out on the right, and we're left with t over 2 pi on the left equals the square root of L over g. Alright, so now we have the square root alone. So we can use the rules that we learned in Unit 7 and square both sides of the equal sign. That gets rid of the radical sign on the right, so we're left with L over g. And on the left we can leave this as t over 2 pi, all squared, as long as we put the parentheses around it. Alright, we're almost there. L's almost by itself, but look at that, we've got another fraction. So we're going to multiply both sides by g in order to get rid of the fraction, and that successfully got L to be by itself. So we have L equals, and then on the left we can write g times parentheses t over 2 pi squared. You could also distribute the squared using the power law here, but it is okay if you want to leave it just like this. Now, if our word problem had asked us to solve for L, all we'd have to do is find G and T, and plug them in, and we would be done. So now let's look at a word problem. So whenever we're solving a word problem using the quadratic equation, or that involves the quadratic equation, you're going to do the following 3 steps. First, you need to rewrite the formula to solve for the letter that's in the question part of the problem. So here's our question right here. And step 1 is to solve for what the question's asking. Okay, so the question says, what was the initial velocity of the object? If we look down here, we can see v equals initial velocity. So we want to set this equation equal to v. So we're going to go ahead and do that. The first thing we need to do to get v by itself is subtract 4.9 t squared from both sides, leaving us with vt equals s minus 4.9 t squared. V is almost alone, but it's being multiplied by a t, so we need to divide by that t on both sides. That cancels out the t on the left, leaving us with v equals s minus 4.9 t squared, all divided by t. Alright, so step 1 is done. Here is the equation that we need to solve because we're looking for v. The next step says find known values from the problem. So we need to read through this problem and figure out what values we already know. So step 2, we know that a stone thrown downward from a 100-meter cliff travels 51.6 meters in 3 seconds. Well, if we look on this side of the equation, we know we need to figure out what s equals and t equals in order to solve for v. If I look up here at the problem, I see it says that t equals time. Okay, well, the problem says that time is 3 seconds, so t must equal 3. And it also says that s equals distance. Well, it says that the stone traveled 51.6 meters, so that must be my distance. So we've completed step 1 and step 2. Now we solve just by plugging the values in. So we're going to plug the values from 2 into the equation. Let's go to a new fresh page for that. So we have s equals 51.6, t equals 3, and we have our equation, which is v equals 4.9 t squared. Oop, let me make sure I'm getting this right. Oh, s minus that. So let's go ahead. S minus 4.9 t squared, all divided by t. So we're going to plug the 3 in here and here, and we're going to plug our s value right here. So v equals 51.6 minus 4.9 t, which is 3, squared, all divided by 3. And if we plug that all into our calculator, which we can do, what we're going to end up with is 2.5 meters per second. So let's go make sure, this should be our answer, let's go make sure our answer makes sense. It says, what was the initial velocity of the object? The initial velocity was 2.5 meters per second. Makes sense? We have completed this problem. So when you're trying these in your homework, make sure that you are solving for the variable that's of interest or in the question. Define your known values from the problem, so make sure you write those out. And then solve by plugging in, always going back to make sure that your answer makes sense with the question. And that's it. Now it's your turn.